Hello and welcome. So we're going to talk about pedigree today, and this is the same pedigree table that is just above here in the notes section. So I'm going to walk through how we can determine what the genotypes are and how this particular trait has traveled through this family tree. So if you remember in the notes section, it said that we do label the generations on a family tree. So I'm going to start by doing that. This is our first generation here, and we always label them over here on this side. So excuse me for just a second. So over here on this side, we're going to label our generation 1. This would be our second generation here, generation 2. And then this row here at the bottom is our final generation, or generation 3. Now, pedigree tables can have more than 3 generations. This one in particular is only showing that. Now remember, every time that we see a square shape, that represents a male, and a circle represents a female. Now, the other thing I mentioned is that we number them. And this is so if we wanted to refer to, say, this girl here, we can simply refer to her with a number so that we can talk about all of the different individuals that are expressed in this pedigree. So I'm going to start up here at the top because that's where we always start with. And this is always our person number 1. And then we're going to go across the generations from left to right. So this will be our 2. Now, since there is nobody else in generation 1, we then drop down to generation 2. And we go all the way back over to the left-hand side, and we continue the numbers. Now, sometimes you will see pedigrees where they do 1 and 2, and then they start over here again with 1. Then you have to talk about generation 1, number 1, generation 2, number 2. I find it easier, as a lot of people do, to just number them from the top all the way through to the bottom. So that's what we're going to do today. So we have 1 and 2. So this gentleman here is going to be 3. This one is 4. Here is 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So we have 14 people represented in this particular pedigree. Now, as you can see, up at the top, I have a key. So this is showing a male and a female that are white, carry the dominant trait, or a capital F. And the ones that are shaded in, male and female, have the recessive trait, or the lowercase f, because remember, this one is dealing with freckles. Okay? This is what we call an autosomal recessive pedigree, because it's tracking a recessive trait. In other words, freckles, when we see them, when we see that phenotype, that's a recessive trait. So the first and easiest thing to do on a pedigree is we look for those people who are expressing the trait. And we know this because they are shaded in. So every single individual that's represented on this pedigree that is shaded, I know is homozygous recessive, because I couldn't see the trait unless they had the genotype of lowercase f, which is homozygous recessive. So I'm going to start by filling those out. And I'm going to start here with my number 2. Okay, so underneath her 2, I'm going to write her genotype, which in this case is lowercase f. And then I'm going to fill in that same exact genotype for every other person in this pedigree that is showing that expression of this particular trait, or in other words, they have freckles. So every person on here that is shaded, I know is homozygous recessive. All right, now, how do I go back and figure out what the genotypes of everyone else on this tree are? Well, in all honesty, it's not quite as hard as you might think. Understanding how genes are transmitted from parent to child, which we know a little bit more about using Punnett squares, will help us determine these, okay? So I'm not going to start up here with number 1. I'm actually going to start with the children of 1 and 2, which, if we recall, remember, this line between them is a marriage line. This shows me that they were married. This is a line that shows me who they have as children, okay? So I'm going to follow that descent line on down. And I can see that they have a daughter, they have a son, and they have another daughter. Now, there's more than 3 people in generation 2. And if you'll notice, that is because their children also are married, okay? But we're going to start with just their children, because those are the ones that have a bloodline to them. So if I start with this girl here, now clearly this dad does not have freckles. So I know his genotype is not going to be homozygous recessive, but I don't know if it's homozygous dominant or if it's heterozygous. However, if I look at his 3 children, does he have any children that have freckles? He does. He has 2. So if 2 of his children have freckles, and I know in order for them to have freckles, they have to have 2 recessive genes, and I know 1 came from mom, but mom can only give 1. Where did the other one come from? It had to come from dad. So dad has to have at least 1 recessive trait, correct? But he also has a child here that does not have freckles, which means she has to have at least 1 dominant gene. Because if she got a recessive from each one of her parents, she too would have freckles, but she did not. So he has to be able to have a dominant gene that also could be shared with his children. So he is heterozygous. She is homozygous recessive. So now I already know these 2 children, correct? But what about her? She doesn't have freckles, right? Now I know mom had no choice other than to give her a recessive gene, but she has to have a lowercase f. Dad could have given her either one though. He could have given her a dominant or a recessive, but she doesn't have freckles. If she doesn't have freckles, she has to have at least 1 dominant gene, which means that just like her dad, she is heterozygous. Okay? Hopefully everybody is with me so far. So let's now start looking at each individual family as these children married. Okay? So if we look, let's start with their son. Okay? We know he is homozygous recessive, and he marries a woman who does not have freckles. So I know she has to have at least 1 dominant gene because we don't see freckles on her. So I know for a fact she has to at least have 1 of these. I'm not quite sure what the other one is though. But if I look at their children, they have 2 children who both have freckles. And for both of their children to have freckles, both mom and dad had to give them a recessive gene. We know for a fact that we got 1 from dad because that's all he has to give. The other one must have come from mom. So mom must also be what we call a carrier or heterozygous. Okay? All right, let's look down here at number 8. Okay? This daughter who has freckles married a man who does not have freckles. And they had 2 sons, 1 that has freckles and 1 that does not. Well, I know for a fact, obviously, if their son here has freckles, he has homozygous recessive, he has 2 recessive genes. He got 1 from dad, he had to get the second one from, that's right, got 1 of them from mom, had to get 1 of them from his dad. So his dad must also have at least 1 recessive trait. But dad doesn't have freckles. So he has to have 1 recessive. He also has to have 1 that's dominant. So just like some of these others, he is heterozygous and what we call a carrier for freckles. Now, if we look at his brother does not have freckles. So we know he has to have at least 1 dominant gene, which he could have gotten from his dad. But what does mom have to give him? She has to give him a recessive. So he is going to be just like his father. He is also going to be heterozygous. So we're going to fill that in here. All right. So that now takes care of almost everybody. So let's come back to our family over here. So we know this daughter here is also heterozygous. We figured that out earlier. And she married a man who does not have freckles. Okay, so he doesn't have 2 recessive genes. Could he have 1? He might, right? So let's say for right now, we know he has 1 dominant gene, but I'm not really sure what the other one is. If I look at his children, his 2 daughters, neither of them have freckles. Now, it's entirely possible that mom could have given him a recessive gene, but they also have to have what? They have to at least have 1 dominant gene because they don't express the trait of freckles, which means they have to have 1 dominant gene, which is going to take that over. So each one of these, I know, has to also have a dominant gene. Do I know for sure what their second gene is, these 3? Not really. Now, if one of these had a child later on, I could figure that out. And so if there becomes a 4th generation, I might be able to figure that out. But as of right now, I don't know. So it could be that dad is heterozygous, correct? And that they got, just like for mom, they could have gotten that recessive trait, or dad could be homozygous dominant. And maybe, but right now I don't know. So I can either leave it written as I have it. I could fill in this blank with a question mark, or sometimes you'll see this written as it could be this or this. It could be homozygous dominant, it could be heterozygous. I don't know for sure, but those are the 2 possibilities. I know for a fact it's got to have that dominant gene. I prefer to write it like this. So if I were to get some more information down the road, or they had children, or they got married, etc., then I can go back and look at what my 2 possible choices were, and I can just circle the one that was appropriate. Any of those different ways are really okay to write. I just prefer to put both of my options written down at the same time. But that's your first example of how to fill out a pedigree. Okay, so again, this is an autosomal recessive trait. And it is an autosomal recessive pedigree. In other words, it tracks a recessive trait through different generations. And while freckles may not seem like it's that important, if we were dealing with something like color blindness or another sort of genetic disorder, I would want to be able to, again, track that through and know, am I a carrier? Could I pass it on to my children? How did my children end up expressing this trait? Okay. We look at somebody like this who maybe didn't have freckles and was surprised to find that they had children with freckles. Now they can look back and understand how that process occurred. Okay. All right. Well, that wraps it up for me for today. And thank you. If you have questions, I'll do my best to answer them in my next. Okay. Oops, let me use this. All right.